So let me put the definition.
Sir, I had a question.
Yes.
Yesterday we did mutual inductance, and also will we be doing transformers again somewhere else, or is it covered?
Transformer is part of AC actually. So when you are looking
Okay.
for the AC video, you will see the last topic is transformer.
Okay.
Okay. Yeah. So that I have discussed in detail. Do watch the AC first and the last lecture if you want to study the transformer.
Okay. Sir.
Okay. So what is EM wave? It is a type of non-mechanical wave, and it doesn't need medium for its propagation, which is medium is not essential. I mean, even if medium is there, it will propagate. If it is not there, it will propagate. So medium is not essential for the propagation of EM wave. Okay. Now, what exactly is EM wave? So as we know, EM wave is two transverse oscillating electric and magnetic field, and the oscillation of the two separate fields always remains in phase, but in different plane, of course. So if I take the electric field on the y-axis for simplicity and magnetic field on the z-axis for simplicity, so the EM wave is basically you can say transverse progressive wave. So it is transverse, it means the direction of propagation of energy and the direction of propagation, or you can say oscillation of the fields, are mutually perpendicular. So the magnetic field will oscillate like this. And similarly, the electric field will oscillate. So in one axis, you can see the electric field is having the sinusoidal behavior. On the other axis, we have the magnetic field having the sinusoidal behavior, and both are what the most important part is, both are time varying. So we have time varying electric and magnetic field. And we know something. Okay, what we know is that a time varying electric field induces magnetic field, right? So B is induced by virtue of time varying electric field, and similarly the time varying magnetic field will induce electric field, as we have seen the EMI chapter. So both are time dependent, which means one is inducing the other, which in turn inducing the first, which in turn inducing the second, which in turn inducing the first, and that is how both are the creator of each other. So an electromagnetic wave is the best example of mutual induction process. You can think about this as the LC oscillation as well. So here the inductor is like the magnetic field. Inductor is storing the energy in form of magnetic field. Capacitor is storing energy in form of electrostatic field. But here they are creator of each other. So both creates each other. Why? Because both are time varying. So because both are time varying, so they keep on creating each other, and that's how they propagate. So one is creating the other, and both are, because both are the creator of each other. At the same time, they create each other. That's why both are always in phase. So if someone will ask you that what about the phase relationship of the E and B, the phase relationship of E and B is always in phase relation. So they have the in phase relationship. So the point which we should remember about the EM wave is that E and B induces each other. So E and B both induces each other, and see, both are time varying. So if one is creating the other which you're creating itself is time varying, so it is also creating the first. So this mutual induction process is a continued process by virtue of which the energy propagates from one form to other form, and you can see that the energy is propagating. Now the direction of energy propagation we give by the something called the pointing vector, which I will introduce shortly. But as of now, we are going to deal with the EM wave in which both E and B we are going to assume as a simplified version of sinusoidal wave. And because both are simplified as sinusoidal wave, so the E I am going to write as, let's call E naught. So we are going to write E equals to E naught. If you want to write in vector form, you can write vector E naught sine. Now, our assumption is it's a plane wave front. So as a wave, it is moving as a plane wave front. And I hope you remember what is plane wave front? The energy propagation in which the amplitude remains constant, we call plane wave front. And because of this reason, we can write E equals to E naught sine, and you can write further as omega t minus x by c. Now c I can replace by v also. So if you are writing in vacuum, you can write x by c, but if you're writing in a medium, I have to write c by what? V. So v represents what? Velocity of light in a given medium. And if you say that the medium is vacuum or air, you can replace v by c as well. And the direction of electric field will be I cap. My bad, j cap. So if you want to write in vector form, you can just write the answer. See, the field is function of x. X is the direction of, what is x? Direction of propagation of what?
EM wave energy.
Yeah. So propagation of EM wave or energy. And depending on the medium, but that's it. Direction of propagation is one thing, but the oscillation is another thing. So the direction of E is always parallel to the y-axis. Okay. So such wave is called the linearly polarized wave. There is a name for such wave, linearly polarized wave. Why? Because both are sticking to their respective plane without altering during propagation. So a wave which always oscillates in one single plane, we call polarized wave, or you can say plane polarized, or it is also called the linearly polarized wave. So such a wave we are going to discuss in detail. And always remember that this linearly polarized wave is the simplistic assumption which we start with and we proceed with. The real life wave will have the superposition of a lot of other, waves. So due to the superposition, in general, it is very complex in nature. But we are not going to discuss that complexity as of now. Our discussion will be based on the linearly polarized sinusoidal transverse progressive wave. You can say all these things. Similarly, you can also express the magnetic field function B equals to the B naught. Again, it's a sine function because, as I said, both are in the same phase. So both will have no phase difference. So the way to express will be same. And interestingly, there is no difference in the function, only the direction, and I can call this as k cap, right? So what is the direction of B? It is k cap. And what is the direction of E? It is j cap. And to find the direction of energy propagation, there is a simple formula called the Poynting vector. It is written as 1 by mu naught E cross B. So E cross B always gives the direction of propagation of wave actually. So tell me, in which direction the light will propagate in this case? If you use the right hand thumb rule, if you write E cross B, thumb will be towards X axis, isn't it?
Axis.
Yes, sir.
So S is called Poynting vector, and it gives the direction of wave propagation. And direction of wave propagation basically means the energy flow. And also you should remember that the concept of a ray, as you study in the ray optics, the ray actually represents the direction of energy flow. It is not representing the electric field or magnetic field. So when I say a ray, a beam, all these words represent the energy flow direction. So when you say a ray is moving towards right, which means the energy is moving towards right. Now the energy is in a different format. So here the energy is in the electric field and magnetic field format. So what we're going to do first is we're going to first find the energy value of any electromagnetic wave. So
Sir,
yeah,
how do we justify that both the fields are oscillating in the same phase?
yeah, the justification comes from the fact that they are the creator of each other, and they create. See, if the more the rate of change, more the value. It means if both are changing at fast rate, both are creating the faster, bigger value. As they slow down, they create a smaller value. So in a way, because the rate of change is proportional, the creation is, I am creating you because of my differentiation. Like let's say d by dt is the creation of B, and d by dt is the creator of B, and both are creator of each other. So the rate of change of both will decide the what kind of magnitude you are going to produce. A bigger rate change, I can say that a bigger rate change means a bigger value we are going to produce. So it is assumed that, I won't say that how it is proved, but it is said that if both are creating at the same time in the same fashion, so they are in the same phase. Okay. So in a way, you can say this is our assumption also, like for this particular propagation, we believe that there is no phase difference. The mutual induction process is making sure that they are coming out in same phase. So maybe it is experimentally seen or perceived, whatever, but because they are creating each other, it is believed that they're creating the same phase. There is no phase difference here.
Okay.
Okay, so here we are going to first discuss the energy part. We are going to discuss the energy intensity power of any electromagnetic wave. So to do so, we know there is something called energy density, right? So what is the energy density for the electrostatic energy density formula? We know the formula is half epsilon naught E square, right?
Yes.
So if I try to write the energy density for the EM wave, I can replace E by the formula E naught square sine square omega t minus kx. As of now, I'm writing like this. I can write the other way around as well, doesn't matter. And you can see this is the a sine function, which means the energy density will vary at a point in space over the time. Okay, so if you are sitting at one particular location of a space from where the EM wave is passing, and if you look at different instant of time, you will see different value of energy density because of the sine function. So it is obvious to find the average, right? So the average will be how much? I can write in short sine square theta because this is entire the phase angle, right? So what is the average of sine square for per cycle?
So 1 by half.
1 by half.
1/2. That's
1 by
half.
2. Correct. That's half. So the average of any sin square or cos square function is always half. You must remember this answer. So it becomes 1 by 4 epsilon naught E naught square. So this is called the average electrostatic energy density. Similarly, what is the magnetostatic energy density? So UV, we know the formula. It is B square by
B square by 2 mu naught.
2 mu naught. So it will again, it will become B naught square by 2 mu naught sine square omega t minus kx. And therefore, if you try to take the average of this, you can take UM also instead of B. Anyway, it doesn't matter. So this turns out to be how much? Average will be, again, I'm writing directly here. I hope you have understood why I'm writing like this. So the energy density will be B naught square by 4 mu naught. So what is the total electromagnetic energy density? What is the average of UEM? The total electromagnetic energy density. So for total electromagnetic energy density, you can just add the two value, right? So you will get 1 by 4 epsilon naught E naught square plus 1 by 4 simply by mu naught. So this is the total energy density at any point of space due to the passing electromagnetic wave. I hope this is clear to all of you. Now,
Yes, sir.
later on, I'll prove, of course, right now I'm going to use it, but later on I'll prove two things, that the electric field and the magnetic field of any EM wave having a well-defined relation, that the ratio of the two is always equal to velocity of light. Okay. So the two are always related with the relation E by B equals to C, and C is equals to 1 upon under root of mu naught into epsilon naught. Don't worry, I'm going to prove today C value. So I'll prove, that's the lecture all about. What I'm doing right now is I'll first of all give you all the formula which you need to know in order to solve question. And then I'll give you the rigorous proof of all this formula, which if you are interested, you can learn. If you're not interested, you can keep in your notes. That's it. So first of all, we'll see the formula. What are the formula which you are supposed to remember and use? So you're supposed to remember the average, total. You're supposed to remember which formula? E by B equals to C. I'm going to prove all of these formula, don't worry. And the C equals to, okay. So now if you substitute the value, why we are doing so? Because the average of EM wave turns out to be, you can express either in terms of E naught or in terms of B naught both. So let me express in terms of E naught first. So B naught we can replace by which formula? When you use the B naught, the maximum value, you will get E naught. So this is always true. It is also true for the maximum value. It is always true for the instantaneous value. So this relation is true for at any instant, or you can use it for maximum. You can use it for the RMS or in general at any instant, whatever is the relation, it is always true. Now, the B naught we can write as what? E naught square by C square. Am I right? Isn't it? Hello, hello. Okay, let me show you
Yes.
something interesting. Just a minute. So what I'm going to prove that epsilon naught E naught square. Prove is actually B naught square by mu naught. Both are same. So what I'll do is I will take the LHS, I'll prove the RHS. That's sufficient. And what is E naught? C B naught. So this will give you the answer epsilon naught C square B naught square. What is C square? Is it proved now? I hope this is simple.
Yes, sir.
Also, you see, in case if in examination you forget that which one is upper, is it E by B or B by E? Always remember E is much stronger than B. So C is a big number. So E by B is C. In case if you forgot. Okay. So if I have proved this, then it means I can express the average energy density so the average electromagnetic energy density we can write as either 1 by 2 epsilon naught E naught square. Why 1 by 2? 1 by 4 plus that will also become 1 by 4, right? I hope you're not getting it. See, our
Yes,
answer
sir.
was this. So we can replace the term, right? So B naught is B naught square by B naught we can replace by epsilon naught E naught square, isn't it?
Yes.
And so this will come eventually this value half. So the total electromagnetic energy density you can either express as 1 by 2 sorry 1 by 2 epsilon naught E naught square, or you can write as B naught square by 2 mu naught. So I think this formula which you have read or studied in electrostatic or EMI chapter, you can use it directly as an energy density. So electric field and magnetic field are two ways in which the total energy density can be expressed. I hope this is clear.
Yes. Yes, sir.
Yes.
Now imagine there is a beam of light. Imagine there is a beam of light. In this beam of light, consider two cross section. Because it's a plane wavefront, so I'm assuming the beam is also parallel because the plane wavefront is something which we can express also alternatively in terms of parallel rays. I hope you can understand this what I'm saying. Yes or no?
Yes.
If it is plane wavefront, then the rays will be parallel because rays are always perpendicular to the wavefront. So this is the ray, this is the wavefront. So this is the wavefront, and this way of representation is called rays. So I'm considering a plane, a beam of light, and I will also consider its a cross-sectional area. Let's consider a cylindrical beam, always meaningful, and the cross-section area, let's say called A, and the speed of propagation of this beam is C. So in time dt, how much beam will travel? Can you guess? So in time dt, it will travel C dt.
CD.
So what is the volume traversed by the beam?
A into CD.
AC dt. So you can take ENO if you have AC dt. So volume is AC dt, right?
Yes.
Okay. With I silent. And Y, okay. So many things. So the volume swept is this much. So how much energy has crossed this cross section? Can you guess? Because this volume, you have swept this volume, it means the energy which was present in that volume is now being replaced by the energy coming from the left side, and the energy which was present in that volume has gone forward, isn't it?
Yeah.
So the energy coming to this space, and we know the energy density formula. So how much energy has crossed? Energy crossing, energy crossing in time dt. Let's call d. I mean, for the simplicity, I mean, mathematical accuracy, you can write as d or. So what is the d? Tell me, what is the d? So it is UEM into d volume. Am I right?
Yes.
So can we write this as okay, let me keep it UEM average AC dt. So energy upon time, what we call energy crossing per unit time is called the power, right? And upon area is called
Intensity.
Intensity.
very good. So the formula for intensity is what? You can see the formula is U average, the average energy density into speed of light. And by definition, this term is called intensity of beam. So if the intensity of beam is given to you, can we write I equals to CU? Of course, to make it more meaningful, ICU. Understood? So
Yes, sir.
intensity equals to speed of light into energy density. Of course, the average value we take. So here, the U is a nice way to represent the UEM. So intensive care unit, I equals to CU. So
CU.
it's easy to remember the formula, at least this way. So for any parallel beam, now remember this derivation is for the parallel beam. If you are not having the parallel beam, do not jump to this formula. You have to rederive for this from the scratch. But in most of the cases which you are going to deal with, this is sufficient. And definitely for JEE-Mains, this is more than sufficient. So we are going to deal with only parallel beam of light for various reasons. A parallel beam will have various properties. So ICU is the most useful formula in this chapter, and many JEE-Mains questions you can solve only if you remember this simple relation ICU. Of course, this formula having the validity for the parallel beam of light. So used for parallel beam. Because the idea of a plane wave front and everything else that we are deriving is for the parallel beam. What you can do is, because you know, if you know the intensity of light, and if it is C into U, so this can be expressed in two ways. Either you can write as U as half epsilon naught E square, correct? And if you use this relation, what is the amplitude of electric field? So given the intensity of light arriving at a point in space, you can find the electric field intensity amplitude at that location using this simple formula. Understood?
Yes, sir.
Hello. Similarly, you could have expressed the same answer. I equals to C into B naught square by 2 mu naught. And that will lead to the formula B naught equals to how much? 2 mu naught I by C under root. So you have to remember these formulas to get the answer. Okay. Is this clear? Now we'll discuss about the momentum carried by the EM wave. Momentum carried by so I hope you remember this basic definition of momentum. For any EM wave, momentum and energy are always related to each other. And if you again remember the Einstein mass energy relation formula, that energy E square equals to m naught c square whole square plus E square c square. Do you remember this formula? The Einstein energy relation.
Yes, sir.
Yes,
Now
sir.
this in this formula we have m naught called the rest mass, p is called momentum, c is the velocity of light in vacuum, and E is called the total energy. So energy is mass, mass is energy. Both are kind of two ways in which the world can or the nature can express itself. Now for EM wave, there is no concept of rest mass, as I have discussed many times. Once again, so for EM wave, the concept of rest mass is zero, right? We don't have rest mass for EM wave, isn't it? So photons are having zero rest mass. So photons will have zero rest mass. It doesn't mean it will have zero mass. It will have the non-zero relativistic mass, but zero rest mass. And if it is so, then energy square becomes P square C square, and this from here you can get E equals to PC. Now this formula I have used many times. So the momentum is actually defined by energy upon speed of light. I hope this is clear.
Yes.
Yes.
So whenever there is a energy, there is a momentum associated with it. So how to express the momentum of a beam? Of course, beam is a continuous flow of energy. So there is a distributed momentum. So momentum is everywhere. So imagine if I give you a beam of light. What nice proper beam. A beam will have energy across its space in which it is present, right? So everywhere, wherever the beam is present, energy is everywhere, isn't it? So the question is, how to express momentum of such beam? See, the answer is we cannot express the momentum of a beam because beam is infinite in length. And an infinite beam, the beam will have neither beginning nor the end. So you can say it will be acting as a ray. So a ray will have no end. It may have the beginning, but no end. For example, the sun is like a source of energy. So sun will create the rays, and the rays will have the beginning at sun, but where it will stop? It's nowhere. So a beam will have infinite energy, but when you're solving question of a beam, you can always cut a part of it. So that is how we always proceed whenever we have the continuous system. In continuous system, we take a part of it, and that part we think as a particle, and that will help you in going back to the Newton's laws of motion era. You can deal with the way you think. Okay, so you can think as you can take a tiny disk, a thin wafer like disk, and if you consider the thin wafer like disk, so definitely this wafer like disk will have some thickness. I can take the thickness as what? Just a moment. Let's call dx as thickness. So in the dx thickness, what is the energy of this part? We know the energy is energy density into
ADX.
ADX. And we also know that the dx we can replace by AC dt, right? Okay, this is how we started, right? So d equals to, so you have to learn how to write these things. So you have to start with this, with the way I'm writing, right? D equals to u AC dt into u or whatever, right? energy density into volume. So UACDT. Okay. You got the elementary energy of in elementary time, or in terms of time, or in terms of x you can express. So what is the momentum carried by this elementary disk? Momentum carried by elementary disk. Tell me how much momentum you will carry. So it is the energy carried by the disk upon C. That's the definition.
Yes.
So always remember that if you know the energy of a beam, you always know how much momentum it is carrying. And this relation is the most powerful and the fundamental relation with which we derive every other formula. And why I'm writing in dP format, because the D is the elementary energy, and so the momentum it will carry is also elementary. Let's call D. Is this clear, guys? Tell me.
Yes.
Hello,
Yes, sir.
okay. Now, if the beam is, facing some absorbing surface in its path, imagine you have a beam and you place something in its path. So it may be a mirror, it may be a black body which can absorb everything. So if a beam is coming, imagine this way. Is it possible for the beam to go beyond the absorbing medium? Will it go this side? The answer is no. Isn't it? Hello.
Yes, sir.
Yes.
If a beam is coming with a speed c, and if it is facing some perfectly absorbing surface, perfectly so in time dt, if there is no obstruction, how far the beam would have moved? CDT, right?
Yes.
So it must have some energy here. It must have some momentum here. But where this momentum has gone? So we can say that this momentum has been absorbed by the surface, isn't it?
Yes, sir.
Because this will have energy, this will have momentum, and the momentum is now gone. So there is an obvious question of where that momentum has gone. You will say the momentum is being absorbed by the surface. In Newton's laws of motion term, we can say this is the momentum imparted to the surface, or this is the momentum absorbed by the surface. The way you want, you can express. So what is the momentum change by the surface? Momentum received, momentum imparted. It is up to you to express in different language. But what we need to understand here is that in the absence of beam, so in the absence of surface, the beam would have moved this much, but now this entire energy is getting absorbed by the surface. So definitely the surface will be heavier than before, isn't it? Because
Yes, sir.
whenever you absorb energy, you always gain some mass. And as a result of gain of a relativistic mass, the total mass of the surface will grow. Although it's negligible, beyond imagination, it's very small. But technically, this is happening. So as you absorb energy, you also get heavier. But when you absorb energy, what you don't realize that you also kind of stop this momentum. See, the momentum was towards the right, and now the surface has completely come into its path. So it is stopping it, isn't it? So this
Yes.
entire momentum is getting destroyed by the surface, isn't it?
Yes.
So when you absorb momentum, actually you experience force. And that is the consequence of Newton's second law, right? The rate of change of momentum is directly proportional to applied unbalanced external force. So the beam is exerting force on the surface. As per the third law, the surface is exerting force on the beam, but that's meaningless. So when a radiation is either absorbed or reflected back by any surface, it is always accompanied with the change of momentum. And because of the change of momentum, it also exert pressure. It also exert force actually, and the force upon a given area, what we call pressure, right? And later on, we are going to term this concept as radiation pressure. Radiation pressure is of great use if we talk about the cosmic traveling. Okay, so when we are going on a voyage from one solar system to another star, or between the planets also. So if we have really large solar panels, okay, which you can open, and if you try to move, propel the spacecraft as per the direction of radiation or the sunlight, it will act exactly as the canvas mast, mast in case of boat. So you use the canvas mast to propel the boat using the wind, right? Similarly, you can open the solar panel of the spacecraft, and using the radiation pressure, you can actually travel. Although it's very slow, but the thing is, it is happening without any fuel. So sometimes we can make use of this radiation pressure, and we can save a lot on fuel. Yeah. So
Sir, is it same like solar wind or something different?
yeah, you can call this a solar wind only. The radiation pressure is actually the solar wind. Okay. And it is actually used. I mean, NASA has used this in one particular situation. I have read somewhere that they were low on fuel and they used this exact radiation pressure to propel for some time. Okay. So these things are always done. And in the cosmic travel, this will be of great use. In the future, we are trying to harness more and more of the radiation pressure so that we can. So, and there are many purpose using the radiation pressure. You see, when you receive momentum, also you receive energy. So energy, you can do it for the other purpose. You can create the current and all. And the force you can, I mean, of course, use for propel. So sometimes it is quite possible that the radiation pressure may change the, the path of travel. Okay. In the outer space, it is quite possible. Because if you are very close to the sun, let's say if you are trying to orbit Mercury, so there the radiation pressure will be more or less compared to Pluto.
Oh,
Because near the Mercury is very close to sun, right?
yes.
So while going close to the Mercury, definitely the solar wind will be very powerful compared to the same solar wind present near the Pluto or Neptune, isn't it? So in fact, I think the NASA used while crossing close to Mercury, because there the radiation pressure was really powerful. Okay. It can also be used to, kind of a natural braking. So if you go against the radiation pressure, you will slow down, isn't it? Now, these things are important, that when to move in which direction so that to face the lesser radiation pressure, and then you can travel more. Okay. So all these things are used. Of course, this is a practical thing, but we are studying. So what we need to realize that the event of absorbing radiation is also an event of imparting momentum. And because of that, we can create something called radiation pressure. I hope the idea of radiation pressure is clear, how we do. So radiation pressure is
Yes.
because of what? Now
Yes.
imagine if you reflect back, let's say if you have a mirror. What is the reflection process? The energy, instead of getting absorbed, it is being thrown backward, right? So the incident beam is coming this way, but after reflection, I'm just showing it separately. It is going this way. Now, definitely the energy is not getting absorbed. You're not getting the energy in this case. But are we going to get some momentum here? And in this case, are we going to get more momentum than before or less momentum than before?
More.
Because to conserve the momentum, in a way, the momentum direction has been reversed. You can think this way. So this was carrying dp momentum this way. Now this is carrying the dp momentum this way. What is the d of dp?
2D.
2 dp.
It is actually 2 dp value wise, isn't it? So when you reflect back the energy, you change the momentum twice, and therefore a mirror will experience more pressure than a solar panel, isn't it?
Yes, sir.
Because in case of solar panel, the absorption is going to be the, the major phenomena, right? But in case of mirror, reflection is the major event, right? Isn't it? And so
Yes.
we can do a trick. We can have a solar panel which is covered with a very thin mirror-like membrane or surface. So when we want to get more propulsion, we can, make this layer over the surface and get more repulsion. And when we need more energy, we can remove it. So in the future, using, of course, they use origami to pack those big size solar panel, and it will shrink into very small volume. So the actual use of origami is in the design of the satellites. Okay, so satellites are actually designed by the origami expert, and in NASA is having many origami expert. Okay, they are basically mathematician. Okay, so they know how to do the folding. Anyway. Now imagine that guy who is the origami expert becomes a carpenter. Then 1 BHK of Mumbai will have furniture more than a bungalow of furniture. I mean, a bungalow having all furniture, if they can do. But nevertheless, they will never become the carpenter because they are anyway doing great job. So reflection will not give you energy, but reflection will also receive momentum. And in fact, reflection will create the greater momentum change, or you can say it will impart more momentum. So to throw back the incident beam or incident energy, we need to exert more force. Okay. So these are two phenomena. And then of course, the third case is when there is a partial absorption and partial. So what will happen when we have the partial absorption? So when you partially absorb the energy, it is as good as saying partially absorbing the momentum, isn't it?
Yes.
Because dp is d by c. So when I say, see, I have absorbed the energy partially. So in a way, I have also absorbed the momentum partially, isn't it? And it is exactly proportional. So if I call alpha as reflectivity, if alpha is the reflectivity, so out of d energy, the energy which will reflect is, so d is coming. So what will go back? Alpha d, isn't it? So
Yes, sir.
what will get absorbed?
1 minus alpha d.
Very good. So now you know that, and therefore the momentum created by the alpha d, the reflection part will create a d of dp by twice of alpha d by c, isn't it? Due to reflection, can we write like this? This is the momentum change due to reflection. Hello.
Yes, sir.
And the remaining part is getting absorbed, which means it will create only d by c. Do you realize this part? So here d of dp I can only write as d by c. Here d of dp we can write as twice d by c. And here we can, this is the d of dp we can write as twice alpha d upon c plus 1 minus alpha See, this is the completely absorbed part. So only one time. But whatever you reflect, it will come 2 times, isn't it?
Yes.
Hello,
Yeah.
hello. So this is very simple. If you just try to understand the process, it is not difficult. And you can get the formula for the force in each case. So what is the force here? So force here is d of dp by dt. I mean, let's try the way you want. So this will become how much? d by c dt. Am I right? Hello, hello. And what is d by dt? What is d by dt? It is power.
Power.
So here, because of confusion, I will use power as W instead of P symbol, because P I'm going to use for momentum. So you can see the force formula is how much? Power upon speed of light. So what will be the formula for force here? I hope you can see this. Hello, hello,
Yes,
hello. And what will be the answer here? Okay, by the way, in this case, so in this case, the answer is very simple. D of dp is how much, guys? If you look carefully, it's very simple. It is 1 plus alpha d by c.
Yes.
So the force in this case is 1 plus alpha W by C. Hello, hello, hello.
Yes, sir.
So this is called radiation force, or force due to radiation. And you can also convert into pressure easily. If you know the force, what is pressure? Force upon area of incident,
Perpendicular.
the surface over which the beam is incident, right? So let's call this topic as, I mean, in fact, this is the topic. And this is how I introduce this topic. It's called radiation pressure. So always derive in this way in terms of energy. Then if you want to express in intensity, you know the relation of power and intensity in parallel beam. For any parallel beam, the intensity into area is the power.
Yes.
Isn't it? Or it's good to write like W equals to AI. So the power is area into intensity. I mean, that's all definition. So one should be aware of converging factor, like how to convert the answer from the power to intensity as per the requirement. So what is the pressure here? So let me find the radiational pressure for complete absorption. So P rad here is how much? The force upon area, and let's call A is the area of the beam. But the force is how much? W by A. But by definition, W by A itself is what?
Intensity.
So it is actually I by C. And again, you will come to realize that the radiation pressure is nothing but average energy density in this case, isn't it? Hello, hello, hello. Do you realize this? No. I equals to Cu, I Cu. So if you put I equals to Cu, the C gets cancelled. What we are left with?
Q.
So energy density is actually radiation pressure. So if you know the energy density, you know the radiation pressure in this case. Similarly, can you interpret the other energy density, other radiation pressure? I'll show you.
Yes, sir.
In the second case, what is going to be the formula for the radiation pressure? It will be 2I by C. Isn't it?
2U.
And it is 2U, and that's logical because what energy coming and energy reflecting back will be part of the same volume.
Yes.
So there is an overlapping of energy, isn't it? So energy density has grown up. Do you realize this? As a result of
Yes.
reflection, we have twice the energy density. Then the
Yeah.
beam energy density, see, there is something called energy density of beam. But when you reflect back in the same path, the energy density there will grow, no? Isn't it?
Yes.
And therefore, this is logical. It's to you. And similarly, in the third case, the energy density will become 1 plus alpha times u, isn't it? That's logical.
Yes.
Also.
1 plus alpha.
Because alpha is only reflecting, right? So from the
Yes.
existing energy density, how much you're adding? Only alpha times the initial value.
Yes.
So all are logical. So I can also say the radiational pressure here is 1 plus alpha I by C. And that's why it is 1 plus alpha U. And all are self-explanatory why we are getting such answer. So do we need to mug up this formula? So is it logical? We can derive also whenever we want.
We can derive.
Now these formulas are only true for the normal incidence. Okay. So all of these answers true for the normal incidence. So now the next part we are going to learn is called so the next part is called oblique incidence. Okay, second it is radiation pressure so we are going to deal with the what will happen if a beam now see the beam is beam only. I'm not changing that part. Beam is beam, but it is coming at angle. So what will be the effect when you come at an angle? Any guess?
We'll take
The
the
area of incidence will increase.
Exactly. So now it will be like the same energy will fall on a bigger area, isn't it? Per unit time.
yes.
So definitely you are going to get a lesser value of pressure, isn't it?
Yes.
So to keep it simple mathematically, I will not draw 3-dimensional, but I will draw a 2-dimensional view. So here is the beam. Remember, my beam is always parallel. So this is the beam part. So now you can see as the beam will hit it, the first part of the beam will hit it. This part will actually spread. The beam energy will spread up to this area, as you can see. So we always take the beam area as the A. So are we touching the A on the base as well? The answer is no. So we are touching a bigger area, isn't it? Tell me, guys.
Yes.
So the question is how much is this area if the angle of incidence, and from the ray optics we know the angle of incidence we define like this. So if theta is the okay, so if theta is this, so you can always do this triangle. This is A. This area is called A dash. And do we have relationship between A and A dash? Any guess?
Sir, A dash is equal to A sine theta. Sorry, A dash sine theta is equal to A, sir.
Think again, think again.
Okay, sir.
Theta is given with
Sir,
respect
A
to
dash cos theta is equal to A.
correct. Very good. So do you all understand that A dash is basically, I mean, A by cos theta or A sec theta?
Yes.
And that's why it's bigger, right? A by cos theta is more than A. So if you all are okay with this, I will take the 3 cases. Imagine if it is perfectly absorbing surface. Imagine the intensity of this beam is I. Can you guys tell me the force exerted by the beam on the surface? First derive it. I'm giving you 2 minutes so that you can also do some manipulation, and then I'll show you how to solve. See, at the end, you're only supposed to remember the formula at least, but no one knows if the JEE-Mains may be very aggressive in asking question and can ask some tough question. If it is perfectly absorbing surface, what will be the direction of force? Will it be normal to the surface or at an angle? Okay, no idea. Hello. Are you guys doing this question?
Yes, sir.
Okay, please go ahead. Done, guys?
So,
Tell me.
sir, so here the area is not taken into account and the F sine theta is like not exactly falling on the surface. So we should take only the cos theta component, sir.
What is the direction of momentum before it is getting absorbed? So the direction of momentum will be in the direction of propagation of light.
Yes, sir.
And if you absorb the energy in that direction, so force will be also in the same direction, isn't it?
Yes, sir.
So force will act at an angle, the way it is shown.
Yes, sir.
So do you guys realize that the force is actually going to act this way only? This is the direction of force. When you absorb the energy completely, the force will be acting in the direction of momentum, isn't it? What is the delta P direction? F is dP by dt. What is the dP direction? This only, no? The initial momentum carried by the beam is this way. And once you absorb, it is 0. So what is the direction in which the force is getting experienced by the surface? This is the force. And this force, how you can write? So we know the answer. For perfectly absorbing surface, it is W by C. Isn't it? Hello, hello, hello.
Yes, sir.
So the answer is on this much only, W by C, which is IA by C, not C dash. I mean, not A dash, IA by C. Because power is intensity into cross-sectional area of beam, not the surface, of course. I think you guys are not able to realize this, right? Hello, hello, hello.
Sir, so the direction does not really matter. Any.
Yeah.
So
Because see,
all-
if I draw a hypothetical cross-section, I know that whatever energy will pass this hypothetical cross-section in time dt, the same will be absorbed here. Whatever energy will cross that
Yes.
line will come to the surface, isn't it? Because everything is getting absorbed. Do you realize this? So whatever energy is crossing this barrier in time dt, the same energy will be absorbed by the surface. Yes or no? Tell me. Tell me, guys. Hello, hello, hello.
Yes, sir.
So the energy received is same. You can always write the same fashion. So the answer will be same. IA by C. What about the radiation pressure? What is the radiation pressure here? That's interesting. So pressure is always due to which component of a force? So who will create the pressure?
The
The
normal
perpendicular,
component.
and the
Perpendicular.
normal component is F,
Cos.
and on which area it is getting incident?
E dash.
So basically the answer is IA by C cos theta by A dash. And what is A dash? It is I by C cos square theta. Do you realize this?
Yes.
So although the force is the same, W by C or IA by C, but the radiation pressure has become I by C cos square theta. Understood? The pressure
Yeah.
has changed. And why it has changed? Because of the spread in the area. Also, it is not just due to the area has definitely increased, but the force component acting normal to the surface has also decreased, right? So F has become F cos theta and A has become A by cos theta. So that's why the overall answer has gone by cos square theta. I mean, there's a double decrement factor of cos. So cos theta, one due to the area increase, and cos theta one due to the component of force. So that's why the answer is cos square theta. Hello, hello, hello. Is this clear?
Yes, sir.
Yes.
Okay. So this is simple relation when you absorb. So next is, I'll go to next. So let's say if you have a mirror, and the beam is coming again in the same fashion. So you all understood the last question? Tell me, guys, yes or no?
Yes, sir.
So if a beam is coming this way, of A is the cross section of the beam. See, cross section is always taken in the direction perpendicular to the direction of propagation of energy. I hope this is clear. Okay, so this is the beam. Let me fill this gap. I hope this will fill the gap. So this is the incident beam. Now it is perfectly reflecting surface. So anyone interested in analyzing this situation? No one. Assume the angle of incidence is theta. If you want, you can try this for a few minutes, maybe 5 minutes.
Okay.
Okay, sir.
Take the intensity as I. Try this out. I mean, try to think at least how you are going to deal with question like this. Okay. Okay, so now let me do this. So the beam which is coming here will reflect back. Okay, something like this, correct? So this is how the beam will come and beam will reflect back. Slow this theta. So the incoming momentum is this way, but the outgoing momentum is this way. So what is the change in momentum? I hope you know. So
Say
d of
2
dp,
dp the cos theta.
it is 2 dp, sorry, 2d e by c cos theta. Am I right?
Yes, sir.
Okay. So the force will be 2w by c cos theta. Because force is rate of change of momentum, right? So can we write the force like this, guys? Tell me.
Yes, sir.
Okay. And if I call this area as A dash, and what will be the direction of force? This force is actually now acting in this direction, right? Because the direction of force will be in the direction of changing momentum, isn't it? So this is the direction of force. Do you realize this? Tell me yes or no.
Yes, sir.
Yes.
And therefore, the radiation pressure will be, because this force itself is perpendicular. So radiation pressure is how much? A by A dash. Hello, hello, hello.
Yes, sir.
Yes, sir.
Are you guys realizing this part? Yes or no? Tell me.
Yes, sir.
Yes.
Yes, sir.
Darsh? No. He's not there. He's there. Okay. So the force will be, the radiation pressure will be A by A dash. So this is the power we can replace by 2IA cos theta by C A dash. And you know the answer will be 2I by C cos square theta. So which is definitely double of the perfectly absorbing scenario, right? In the perfectly absorbing case, the answer was I by C cos square theta. Now what is the answer? 2I by C cos square theta. So that's very logical. You can always remember that whenever there is a reflection, it will be double. Okay. What about the third case, which you all know? So now the surface is having partial reflectivity.
We I by C 1 plus alpha cos.
Correct. So can you derive it from scratch? I mean, the way you have learned, that will give you the confidence that how to solve question of radiation pressure. So it will reflect, but it will reflect a partial value, right? Not full value, right? Isn't it? So the way you can think is, if DE is coming, only alpha D is going back And what is getting absorbed? So this is the energy relation. I hope you can understand this. Hello, hello, hello.
Yes.
And assume the angle of incidence is theta. So everyone try to derive it. First, you find the net force. Find the net force on the surface. And then a radiation pressure. Solve it. I will be back in 5 minutes.
Yes. Yes.
Yeah, tell me.
Sir, F net is 1 I by C, sir, W by C, 1 plus alpha cos theta.
Mhm. It is the answer.
Sir,
Yeah.
Acha, I just do the
Sir.
perpendicular.
Yes, tell me.
sir, 1 minus alpha plus 2 alpha cos theta W by C.
Mhm. I think none of you will get this answer. Let me explain.
Okay, sir.
So first of all, you need to realize that a part which is getting absorbed will create the force this way. So absorption will create a force this way, right? ABS. Okay, let me do better. So if this is the surface, the momentum imparted by the absorbing energy will be like this. And the direction in which you absorb the energy is the direction in which you exert the force. So due to the absorbed energy, the force will be. Tell me.
One minus alpha W by C, sir.
Yeah. So this is 1 minus alpha W by C. That is the force. But there is one more force due to the reflection. And the force due to reflection will act this way, right? So what is the force due to reflection part?
2 alpha dp. I mean cos theta W by C.
Yeah, so 2 alpha W cos theta by C, right?
Yes, sir.
So what is the net force? If you use a vector sum, no? It's very complex.
Yes,
Answer.
sir.
It is FABS whole square plus FREF whole square plus 2FABS FREF cos theta. So who got this answer? No one. So now you understand how the force is calculated here. Hello, 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 hello.
Yes, sir.
Okay. So once you get this answer, you can substitute the value, and I can take common as W by C. I can take common. So under root will be having what value? 1 minus alpha whole square plus 2 alpha cos theta whole square plus, oh my God. I hope this is correct. So this is the net force. Tell me, guys, yes or no? Hello, hello. Am I audible?
Yes, sir.
Yes, sir.
So the net force part is clear, yes or no? Tell me.
Yes, sir.
Now to find the radiation pressure, but the radiation pressure is easy to find because it is FABS cos theta plus F reflected, right? upon A dash. You can check the diagram and you can understand why this is so. So F reflected plus ABS cos alpha. Am I right? Hello, hello. And that is why you will get the answer as 1 plus alpha W by C cos theta upon A dash. And now if you substitute the W as IA, it becomes I by C cos square theta. So is this clear, guys? Tell me.
Yes, sir.
Hello, hello, hello. Okay. So there are 2 or 3 more questions that you should be aware of. It's famous. So we have a hemispherical ball. Okay. So we have a point source of energy, light, whatever. And this will emit radiation in all direction readily output, right? And the power of this source is W watt. So what is given to use the power of the source? This is perfectly absorbing surface. You can choose radius as R. I mean, the source is kept at the center of curvature of this hemisphere, or you can say center of the base of this hemisphere. So how much force is exerted by this source on the sphere? Find the force on hemisphere by the source of light. I mean, basically it's due to the force due to the radiation pressure. So how you are going to proceed here?
Sir, is it W by 2C?
Yes, something like this. Either W by 2C or W by 4C, something like this.
Okay, sir. Sir, W by 2 is dE by dt.
Yeah, W is d by dt.
Sir, no, sir, W by 2.
W by 2. Okay. See, to find the first of all, you need to realize that this is the point source. Will it create the parallel beam of light? Yes or no?
No, sir.
No, that's correct. So the parallel beam of light idea is not going to work here. So we need to, first of all, we need to find the intensity close to surface, isn't it? So from a point source, the energy will spread out, isn't it, guys? In all directions.
Yes, sir.
So if I consider an elementary patch, if I consider an elementary patch over the surface, then I can feel or I can see that a conical shape energy will arrive here, right? Tell me, guys, is this clear so far?
Yes, sir.
Everyone tell me, please. I'm not hearing from the guys. Parv,
Yes,
Yusuf,
sir.
tell me. Now, once we have this conical shape area, I mean, beam coming to this elementary area. Now, for a small time dt, the energy absorbed we can find if I know this area, right? So energy falling over this area will be the intensity close to that area into dA is the power.
Yes, sir.
Yeah, intensity into area is power. Power into time is energy
Energy.
absorbed,
Energy.
and energy upon C is the momentum.
Yes.
And because this is completely absorbed, so D of dP is the d by C itself. Yes or no? Tell me, guys.
Yes, sir.
Yes.
So d of dP by dt will be how much? Oh. So this will be, yeah, if you differentiate, you will get the answer. dF equals to I dA by C. Am I right?
Yes, sir.
Yes, sir.
Okay. Now, once you get this force, what will be the directional force? Because it is completely absorbed. So the directional force is like this only. So the force will be acting in the radial direction. Yes or no?
Yes, sir.
So because of symmetry, if I choose this angle as theta, because of symmetry, what will be the net directional force?
Sir, downwards.
It is going to be vertical downwards because of symmetricity, isn't it?
Yes.
Yes.
So we have to only find the y component of force. Let's call dfy. So this is dfy will be equals to, can we say df cos theta, isn't it? Tell me, guys.
Yes, sir.
Hello.
Yes.
So now the answer is I by C into dA cos theta. Okay. So I will write from here. So what is the force? What is the net force acting on the body? So the answer is I by C into dA cos theta. And dA cos theta integration will give you how much? Any guess? Pi r square. It is pi r square I by C. But what is given to us is the power, and we know intensity is defined as power upon area over which you fall, which is
4 pi.
See, the energy is actually falling on the entire area, no, 4 pi r square. And therefore, pi r square, I mean, you can replace I by. So, therefore, the Fy is how much? Pi r square by C into I is how much?
Sir, should it be W by 2 pi r square?
No, you're making again mistake, same mistake. I think anyone measures the mistake. The energy you are receiving is a different thing, but energy is spread by the source is how much?
It should be by 4 pi r square.
Or if you want to write by 2 pi r square, then energy, the power received by is also 1 by 2 only, no? W by 2.
Yes, sir.
So it's the same thing. And therefore the answer is
By 4.
if it is perfectly absorbing, then perfectly reflecting, then it will be
Same
double.
answer.
No, double.
Double.
Reflecting.
Four should be double.
W by 2C, right?
Yes.
Because that incidence is again normal. It is perpendicular, isn't it?
Yes.
Yes.
So this is perfectly absorbing. You can do it for the perfectly reflecting as well. So question can be asked this particular way. So pi r square I by C or W by 4C and whatever. So you have to learn to write these things. I mean, see, it's a unless you will not practice enough, this kind of elementary momentum writing is going to be a difficult task for most of you. So it looks really easy, but when you try to derive it, you may find this to be a bit difficult. The last question is, a beam coming and falling on a sphere. So let's say we have a sphere of radius r. And a beam having dimension that equals to the diameter of this sphere is falling over it. So it is the case of the radiation coming from the sun and falling on the earth, right? So at least the entire earth will be covered.
Yeah.
Even if I make it bigger than this, it will not matter, right? This part of the beam is of no use, isn't it? So
Yes.
that's why we only consider this. So this is the case of, if the energy is coming from the sun, then what is the radiation pressure on the earth as a whole? Okay. And we know that what is the intensity of the beam coming from the sun. Those things we can always think about. So the earth can be assumed as, you can take this spherical object as either perfectly absorbing or perfectly reflecting or something in between. What is interesting is that no matter what you assume, the answer is same in all cases. So I'll just show it for the which case you want to see, the perfectly reflecting, right?
Anything is fine.
Pardon?
Sir, anything is fine.
Okay, okay. Fine. So a beam is coming, and how we draw the diagram is we assume a cylindrical beam of width. So how, okay, it's difficult. I know. So consider this part of the beam. Why are we considering this way? Because this area we can know how to find, right? This is the area of the beam because this is in the direction perpendicular to the energy, right? Hello, hello, hello. So if I consider R and this is dr. Oh, I'll go other way around. So imagine from center to take the axis here. So let's say this is theta. This is d theta. So what is the radius of this beam?
R sine.
R equals to R sine theta. So generally we express in terms of radius of the sphere, every quantity. And okay, what else? So the width here is, the slant width is how much? R d theta, isn't it?
Yes, sir.
Yes, sir.
But the question is, what is this width? I want this width, no? I want this one. This length. What is this much? How to find?
Cos.
Yeah, you can always do this, no? This is R d theta. And you can extend this line. So of course you can do this. This is over the surface of the sphere, and we want is the perpendicular area, cross-sectional area. I mean this width. This width is how much? Yeah, so you can draw something like this. I mean, it's not difficult. It's very mathematical, I know.
Yes.
Hmm. So to solve this question, you have to be a bit artistic as well in drawing the diagram. Okay, so I hope you can see this. This is R d theta. So this is actually, it is simply projection, right?
Yes.
It is always R d theta cos theta. So what is the dA? Because you see, if you remember the dA and dA dash, I want dA, right? This is the dA. So dA we can attach how much? 2 pi small r into R d theta cos theta.
And R we can write R sine theta.
Exactly. So we can add 2 pi R sine theta R d theta cos theta. So it is 2 pi R square sine theta cos theta. Let's keep it this way only. If I know the dA, if I know the intensity of beam, I know what the energy will cross or pass through that elementary area. So how much energy will cross that area? So D equals to how much? In time dt we can say I dA, intensity into area is power. Always think dimensional, you will get the right answer.
Yes.
So the power is I dA, power upon power into time is called energy. Always think this way, I dA power power into time, energy. Energy upon C, momentum, isn't it?
Yes.
This is momentum part. Okay, we'll find the change in momentum. Now, D of dp when I write, it means if it is getting absorbed, reflected, or whatever. So again, this is a difficult diagram. If you assume perfectly reflected surface, then this is theta. So how the beam will scatter? At the same angle on the other side, isn't it?
Yes, sir.
All are difficult, not very easy. So if you think it is perfectly, I'll take any case, a random case. Okay. So which case you want? Alpha is the reflectivity. I will take in general case, right? At one go, it will take care of everything, right? And if I prove, then it's interesting. Okay, so no. Okay, what I'll do is I'll only keep just a moment, only D part. So are you guys getting the D part first of all? If alpha is reflectivity, then the energy going this way must be alpha DE.
So the differentials aren't matching up, right? Like there shouldn't be more than one differential.
It is happening entire surface on this ring. I'm showing only one part. It's a three-dimensional view. I mean, three-dimensionally it is happening.
Okay.
It's difficult to show, right? If I draw everything, you know what will happen.
Yeah.
Neither you will get something, now not I will understand anything. So both will be at loss. Okay. First, understand what is the incoming energy. This D is the incoming energy over the surface of the sphere in time dt, yes or no?
Yes.
You all are getting this point? The D is the incoming
Yes, sir.
energy. And after reflection, only alpha part will go away. And the rest part will get absorbed by the surface. No. The energy that will be absorbed by the surface will exert the force in the direction of propagation. If you remember, dF absorbed, because the beam is going towards the left. So if you absorb something completely, the force will be on the left, yes or no?
Yes,
Yes.
sir.
But the reflected light will create the force in the line of symmetricity. So this is the dF reflected. I hope you remember this. Very challenging, eh? And dF reflected will have symmetry again. Only the axial component will survive and rest will cancel out from all direction, isn't it? Not getting, eh? Actually, DF is acting this way, isn't it? Hello.
Yes.
Sir, are we considering for the ring?
Yeah, only ring.
Okay, sir.
We are
Sir,
only
the entire
considering.
ring.
Yeah. See, we cannot
Oh.
consider everything at once, right?
Yes, sir.
So the DF part is actually in all direction, isn't it? And so the component which will survive is the axial and the rest will get destroyed. So what is the net force experienced by the sphere over the ring part? I'm asking what is the net force only over this part, not the entire sphere. Because this part is mathematically feasible to write. Okay? And if you realize, the answer is dF absorbed plus dF reflected cos theta. I hope you can understand this part. Hello.
Yes, sir.
The dF absorbed, I know the answer. It is 1 minus alpha D by C. That I can write directly. You know why? Because this is the momentum absorbed. So this is the okay. This is the D of dP due to absorption part. So due to the absorption, this is the energy absorbed. Am I right, guys?
Yes, sir.
And due to the reflection, the answer should be. Tell me. No, is going to be 2 alpha D by C cos theta. Correct? Into cos theta. Isn't it?
Yes, sir.
So we have two forces, right? The reflection will create, okay, I think it's still this is not clear. What is the D of, I mean, how to say this? D of dP due to absorption is 1 minus alpha D by C. Am I right?
Yes.
Tell me, guys. And D of dP due to the reflection is 2 alpha D by C cos theta. Tell me, yes or no?
Yeah.
So the second term will give you the reflected force, and the first term will give you the. But the force will be not this, because I mean this is the force acting in this. This is the momentum in this direction, and we have to take the cos of that. I mean, it's a into cos theta. I have brought it this way. Because the net force will, because it's not only acting, you know, it's acting over the ring. So even that cos theta will survive. Yeah, quite difficult. Anyone getting this part? No one.
Sir, a minute. Give me.
See, you can think this way. If I just consider elementary of elementary, too much of elementary. So for that elementary of elementary, we can call this as a D of DF.
Yeah.
And then it will become really complex. It will become D of DA. And then the answer will be D of DA I into D of DA into DT upon C. It's a lengthy thing. So you have to
Okay.
assume, okay, this is
Understood.
correct. Yeah.
One theta is from the reflection and the other is from the component of the force.
Component. Yeah, component of reflection
In
for
the radial direction.
in the axial direction.
Yeah, sir. Axial.
See, the reflection will create the radial force, and that radial force will have the component which is the actual force, right?
Yeah.
Yeah, I mean it's not easy. I can explain. It's not easy. Yeah. Okay. Okay. So what we're getting the answer here? 1 minus alpha. And D we can write as I dA dt. And dA itself is this much, which you need to further substitute and integrate. So who will take the onus of substituting dA and integrating this? net force BFX. Yeah.
Sir, um, sir, I find that I'm getting confused while taking the elementary DA parts between
Yeah.
A and A dash.
Okay. A and A dash. The A dash is the surface over which it falls on the sphere, and A is the area which is normal to the direction of propagation of beam, and my beam is propagating towards left. So this is the
Okay, sir.
this is the cross section area normal to this,
Sir, yes, sir.
and I'm taking the elementary of that, which is coming as a cylinder. But once it falls, if you look carefully, this is the sphere of the surface of a sphere. So when you have a beam coming this way, the same beam is falling this way, right?
Yes, sir.
And because it's a curve, so if I take a small piece, it is like a flat.
Yes, sir.
That's why I've taken the elementary part. This is a flat.
Oh, no, sir. Actually, like in the conversion of D to I DA dt, sir.
D to
DE to I DA dt, that part.
okay. So what is the intensity I given to you? So intensity into perpendicular area is the energy flow rate, the power.
Sir, why the perpendicular area?
The way we define the intensity is amount of energy crossing a given cross section per into area per in time. So if I draw a cross section of this elementary ring shape, how much energy will cross?
Oh,
So
right.
so intensity is given to you already, I. Okay. And
Yes, sir.
the energy crossing this area will be I
I
dt.
dot D. Yes, sir.
I mean, of course, if you can write A as dA here because it's elementary. So I dt is called the intensity. Sorry, I into A is called power. D by dt. So
Yes,
how
sir.
much energy will flow?
Okay, sir.
Okay,
Sir,
understood.
yes, sir. So energy, it does not really matter like on how much surface it's falling, but then when it is passing as wave, that
Yeah,
cross
yeah.
section is what we are
Correct,
supposed to consider.
correct. So energy here is not static; it's a continuously, I mean, moving forward, and so we have to make a window through which you calculate how much energy is passing. Because
Yes, sir.
whatever is entering that window is arriving on the sphere, isn't it?
Yes, sir.
Because it's because of the continuity, it's happening throughout the volume of his space. There is no gap.
Yes, sir.
Okay, so you have to do the two separate integration, the dA and dA cos square theta. So can you guys do it? The dA and dA cos square theta integration? Anyone?
Yes, sir.
Please do the integration separately to get the net force. Let's keep all. Basically, what I have written here is d of dp in the x direction. Let's call this as x. That's more meaningful, right? And this is the dfx. Anyway, this question, I will tell you what to remember. There's a simple formula. It is IA by C, that's it. Which A? The projection area. But anyway, let's see how you're getting the answer. And theta will go from where to where? From where to where? The limit of integration is from where to where? Tell me, guys.
0 to pi by 2.
Very good.
So,
Yeah.
I pi r square by c into 1 minus alpha sine square theta minus 2 alpha by 3 cos cube theta.
No, why this? When you integrate from 0 to pi by 2,
Limits. Yeah, I got it.
who will put the limit? After limit, tell me what is the answer. I'm
So,
expecting it should be free from the alpha.
okay.
Yeah, tell me what is the answer?
So, no, so I'm having 1 plus alpha I pi r square by 2c.
1 plus alpha I by r square.
Sir, I pi r square by
Acha,
2c.
I pi square 2. Yeah, that's quite possible. Okay.
Sir, but the answer should be free of alpha.
Yeah, this is what I expect.
Okay. Sir.
Okay, let me check. Either I have made some mistake here, maybe, quite possible. Okay, so fx turns out to be 1 minus alpha I by c. And dA is how much? 2 pi r dA is 2 pi r square sin theta cos theta. 2 pi r square. D theta is missing. Okay. Plus,
Sir, yes, sir. I'm getting I pi r square by c.
yeah, now that's the right answer.
Okay. Sir.
So second term will be this much, right? Isn't it? Sin theta cos cube theta, isn't it? That's it.
Yes, sir.
So 1 minus alpha. Okay, I can take pi r square sin 2 theta d theta, right? Minus cos 2 theta by 2. R square. And I can take cos theta as t. So I can do this integration separately. So if you take t cube minus t cube dt, t power 4 by 4, right? Minus cos 2 theta by 2. So how much is that?
1 by 4, sir.
Cos power 4, 2 is 0. 1 by 4. Yeah. So now, and this is how much? 1?
Yes, sir.
So this is 1, no?
Yes, sir.
So 1 minus alpha I pi r square by c plus cancel alpha I pi r square by c. Okay. So this is the proof that no matter whether you absorb partially, fully, so the force is going to be a fixed answer. It is always I into projection area upon C. That's why this question is very famous. And I just wanted to prove that even if you start with alpha as a reflectivity, the answer will remain unchanged. So the force on a spherical object due to any beam, parallel beam, is always how much? I into projection area upon C. I hope this will be clear to all of you. Hello, hello, hello.
Yes.
Yes, sir.
Yes.
And this we can further extend to maybe in the J advanced level, they may create a question like this. So at first go, you won't realize, but eventually you will realize. So this is, what is this? Sunrise. Oh, this is sun. So in the sun frame, sun is really big. And then far away, there is a small planet. Far away. The Earth. Okay, I'm looking from the sun frame. If I look from the Earth frame, then Earth is large and sun is small. The whole idea is if I assume the temperature of sun as T and the radius of sun as RS, the distance between the Earth and the sun center as D, Stephen constant as sigma, then what is the power emitted by the sun? So we know the power emitted by the sun is given by sigma A T power 4. If you don't remember, this is from the Stephen's law. Okay, don't remember. Stephen said that dq by dt upon a dt. So the amount of energy radiated by the planet sun, or sorry, star sun, per unit area is how much? Sigma into 4th power of absolute temperature. Come on, guys, tell me yes or no.
Yes.
Okay,
Sir.
this is Stephen's law. I mean, those who don't know, you have to Remember, this is called Stephen's law. That every spherical body, or not body, any body at temperature T will emit energy at this rate. And if this is the power of the sun, because this is the power, the intensity close to the earth will be intensity near the earth. So because D is very large, it is 1.5 10 by 11 meters, called the one astronomical unit. This is called AU. So one astronomical unit is the distance between the sun and the earth, which is roughly. Okay, anyway, the intensity of sun close to the earth will be the power of sun upon the sphere over which energy will fall, which is 4 pi d square. Do you realize this? Maybe. So this is the intensity formula, isn't it?
Yeah.
Because after traveling d distance, energy will spread out over the sphere of radius d. Hello.
Yes.
We
sir.
have
Yes,
done
sir.
this. Yeah. And therefore, the earth will actually receive a parallel beam of light. Very small. The earth will receive a parallel beam of light of this intensity, which I have derived here. So how much force earth will experience when the sun is at zenith? Yeah, maybe we can do this. So force experience by earth due to radiation pressure. So can we say this is I into pi radius worth? If you remember the answer which we just derived.
Yes, sir.
And does it matter whether earth is perfectly absorbing or reflecting or whatever?
No, sir.
Because we have proved that the answer is independent of alpha. Tell me guys, yes or no?
Yes, sir.
Yes, sir.
So
Yes,
no
sir.
matter what, the earth is going to experience this force. And now I can substitute the I formula, which is P sun by 4 pi d square the pi gets cancelled, and P sun we can write as sigma. Too much. Okay, just how much you got? P sun R power of sun RE square by 4d square C, right guys? But the power of sun is sigma into 4 pi sun area T power 4 upon so finally you can see the force on earth will be function of temperature of sun. So this question will be asked in JEE Advanced in coming future, maybe not this year, maybe next year, next year. So I can expect question like this. So they always mix the radiation pressure with the chapter radiation and temperature. And that can be done in fact, isn't it?
Yes.
Okay. So we are done with the difficult part. Now I have to just do the formality, the Maxwell equation, and the derivation of speed of light. So Maxwell had the intuition that the laws of electromagnetism are not independent laws, rather they are interconnected. And in fact, he established the relation. And then a mathematical formula was written for the laws of electromagnetism by a mathematician, Oliver Heaviside. But now we call Maxwell equation, but actually it was written by this guy. So he formulated this all formula. But the intuition was, of course, it came to Maxwell first, and he was very senior, I think. So this guy should get some credit, at least, in my classroom. So first of all, we need to know the Maxwell equation. So what is the Maxwell equation? It is a collection of laws of electromagnetism. That is electrostatics and magnetism both. So Maxwell equations. So what are the laws which we know? So the first is called Gauss law of electrostatic. What is that? E dot. So electrostatic flux is equals to
Q enclosed by epsilon.
this way of writing is called the integral form of. This is called the integral form. But when you enter the BTech first semester, they will use the differential form. And in differential form, the dot product over the area will become the divergence. So we write a del dot E. So if it is dot there, here it is also dot. And then the charge replaced by
Rho enclosed.
the charge density. Because now a differential form is always the point function. So you can imagine elementary volume enclosed in space, right?
Yeah.
So the density of this small volume is constant, rho. So the del dot E is equal to rho by, no, this is not required. I'm just writing because in future you will see these things actually. So it's good to be aware of it. Differential form. We can derive the formula either by integral form or differential form. I'll just try to keep as per the JEE syllabus, not to go, but I can show you both. I mean, if time will permit, I'll show you both eventually. So the second law is called Gauss law of magnetism. So in magnetism, the thing which we must remember is called the monopoles do not exist. So the north and south always comes together. So if you have any enclosed surface, and if you think of any magnet, so in case of magnet, the lines of force is always close, which means the lines of force will start from the north pole, will move and will come back to the south and will circulate like this. So what is the net flux through the closed surface? So is it possible to have any flux through closed surface?
No.
Due to any
No,
magnet,
sir.
it is not possible, because whatever will emit will come back, and therefore it will always have zero common contribution to the flux. That's why the Gauss law of magnetism says that, or you can write is that B dot dA over the closed surface is always zero, or del dot B. I hope this is clear, right?
Yes,
The
sir.
third is called, the third is interesting. So third is called Maxwell Ampere circuital law. So earlier I wrote the Ampere circuital law in the chapter of magnetism, but now I'm writing Maxwell also as additional. And the reason is you have to go deep dive into some history. So imagine your typical RC circuit. So we have a resistor and we have a capacitor. So imagine if I have a contour like this. So what is contour? It is the edge of a open surface, right? For every open surface, there is always contour.
Yes.
Contour is like the, if you have the any poly bag. So the opening is, if you look at the sketch, the sketch of the opening, it is the contour. Okay, contour is for open surface. For closed surface, there is no contour. So one contour can have how many surfaces? How many open surfaces? For a given contour, how many open surfaces we can draw?
Infinite.
Infinite. So imagine some charge is getting deposited. And current flowing is I. This is the Amperian loop. So Ampere said that the line integral of magnetic field over the contour is equals to mu naught into I enclosed. I hope you remember.
Yeah.
So for this contour, what you can see that the I enclosed will be I, correct? Isn't it?
Yes.
But if I draw the same contour here, or if I draw a surface like this, so what is the current flowing through this part of the surface? I can draw this surface, I can draw this surface. So how much current is passing here? See, current is
Cycle
passing.
current with the exception of leakage current.
No, the gap will have no conduction current, isn't it?
Yes, sir.
through gap, we cannot have any current of the wire, isn't it?
Yes, sir.
So if I draw something here, there is a problem. So if I try to write the Ampere law for the same contour, but if I draw a surface like this, the current crossing this surface is null, zero. So this is called contradiction. I mean, at one hand, the Ampere law is true, at other hand, the Ampere law is false. But if a law is universal, it should be true in all cases, isn't it? So to resolve this ambiguity, what Maxwell proposed was another variety of current. And what he named that current, if you remember? Anyone?
Displacement current.
Displacement current. Very good.
Sir,
Yeah, tell me.
sir, I don't exactly understand how the loop is made.
Okay, like this. You can make the loop like this. Rather, I'll draw something like this. Or you can also make the other way around. Imagine so loop means what? I mean, loop is if you think this as a loop. Okay, if you think this as a loop, then what is the current crossing this loop?
I, sir.
So the B dot dl will be
Say
mu naught
mu
into
naught
I
in-
enclosed.
Yes, sir.
Actually, I mean, I should have written, I mean, how to say this. You can do the way you want.
Okay, sir.
So draw like this.
Okay,
So,
sir.
so the B dot dl equals to mu naught into I enclosed, and I enclosed means what will cross the boundary or the surface, right?
Yes, sir.
So if I draw a boundary like this, what is crossing this boundary? If I ignore this part, the earlier part.
Sir, but isn't that the
You have to take either this or this, I'm saying. Don't take both. Either this is your surface or
oh yes, sir.
so if I see I have the same contour in both cases. Contour is this one. So
Yes,
B
sir.
dot dl, if I draw contour this way, then I can say the current crossing is this how much?
Sir, the first
I.
case is I. Yes, sir.
But in the second case, it is zero, no?
Yes, sir.
Nothing is crossing that surface, isn't it?
Yes, sir.
So in one case it is true, in other case it is wrong. It means this must be something wrong, correct?
Yes, sir.
So this issue was resolved by Maxwell. He said, see, what he said is, okay, actually you can draw this way. I mean, let me just remove this. Just a minute. This will make better sense. You can draw something like this. Okay. So from if I take this surface, and if you think of this surface, so the current which I am drawing here, it is passing through the red colored surface, isn't it?
Yeah.
But it is not passing through the white colored surface or the blue and white. So Ampere law is saying that B dot dl is mu naught times current enclosed, and the current enclosed means what current will pass through the surface. That's like the penetration. So definitely it is penetrating on the LHS, the left hand side of the plate, but it is not penetrating on the right hand side, isn't it? So this is called the discontinuity. So to explain the discontinuity, Maxwell actually introduced a new current. What we call today is displacement current. And what is displacement current? So we know that the plates, the charge on the plates will create an electric field between the plate. But as charge will vary over time, the electric field will also vary over time, isn't it? So the flux through this area will also vary with time. And whenever there is a change of electric flux through a given area, it constitutes displacement current. So the way of writing is very simple. The charge on the plate is how much? Okay, or you can say, what is the electric field between the plate? Sigma by epsilon naught. I hope you remember this. So sigma we can write as, and how to write the sigma? It is charge upon area. So charge is how much? And what is E into A, guys? Tell me, what is E into A?
Flux.
Electric flux, right? Electric flux between the plates.
Yeah.
Now, if I differentiate both sides, the LHS is called the conduction current, but RHS is called displacement current. And they must be equal because of continuity relation. So if IC is flowing here, so whenever you see there's a gap in the vacuum or through the vacuum, what flows is called ID or the displacement current. So IC is called conduction current, which is due to charge. But ID is not due to charge, rather it is due to the electric flux. So due to time varying electric flux. So in empty space, we do have current. So electromagnetic wave is flowing through the empty space and it constitutes a current in the space called displacement current. And also the finite speed of light suggests that the empty space or the vacuum also offers some resistance. And I have explained many times, what is the resistance offered by the vacuum? Anyone knows? So the resistance offered by vacuum is under root of mu naught by epsilon naught, and it turns out to be roughly 377 ohm. This is not resistance, this is called impedance of vacuum. A zero impedance means the velocity of light becomes infinite. So if something is finite, it means there's some opposition. Okay. So now what you are supposed to remember? The simple formula. I have done this derivation in the past also. Let's do it again. So the displacement current, how we write? Epsilon naught. So ID equals to epsilon naught d phi E by. So the Maxwell Ampere circuital law, we write as V dot dl is equals to mu naught into I conduction plus epsilon naught d phi E by dt. Or you can say I. Let me write down in two steps. IC plus ID. You have to include both to make it a complete equation or universal equation, which you can further write as IC plus. What else you need to remember that in vacuum, in charge free region, in charge free region, IC do not exist, and therefore when you're solving this Maxwell equation for empty space, the formula we write is mu naught epsilon naught. So this is the formula. Now slowly you can see the speed of light somewhere, right? You can see somewhere. Is this clear, guys? So this is the third equation of Maxwell. So the first was Gauss law. Second is the first and second is Gauss law. The third is the Maxwell. So what is the fourth equation? The fourth law of Maxwell. Oh, one more thing. So what is the differential form? Any guess? So line integral we replace by the cross product. Del cross B. Surface integral, divergence, and line becomes cross. Cross means kind of contour. And the way of writing is how we write? Mu naught J plus, you can say JC plus. Any guess, guys? You can say del E by del T. So the flux is replaced by the electric field. Because you can see area will go away, right? From everywhere. So if you remove the area, you will get this term, right?
Yeah.
So this is the differential form. And in free space, you know how to write. But nevertheless. And the last is okay. In general, in free space, of course, all are vector form. All right, guys. So this is the answer. I hope this is okay. The last is called. The fourth Maxwell question is. Tell me, guys.
Faraday law.
Correct. So what Faraday's law says?
Sir, EMF induced is equal to minus d magnetic flux by dt.
Yeah, but in the context of EM wave, what we should say is the line integral of electric field vector. So instead of using the E induced, you can also say the line integral of electric field vector over a contour over a contour is equals to minus d phi b by dt. So that's what we call E induced. You can also call E dot dl. And why I'm writing like this? Because this can be converted into differential form. Any guess what should be the differential form? The line integral is always curled.
Nabla cross E is minus dB by dt.
Where minus d by. So generally we write a not like this, we write as partial difference of del v by. I think here I should also write partial, but yeah, that's it. Let's change it here. So why partial, guys? Because we know the electric field is function of space and time both.
Yeah.
So it's a multivariate function, but yeah, that's okay. In JEE context, all wrongs are right. Completely. Yeah, it's good to know the exact. This is what was here? Daily by. Okay, so these are the equations. Just be aware of, and these are called the Maxwell equations. So that together the four. So del dot E del dot B del cross B and del cross E together we call as Maxwell's equation. I hope this is clear to all of you. So you're supposed to know the different integral form, but after class 12, the only thing you will come across is differential form. Okay, guys, is this clear? So we are going to derive the speed of light using the Maxwell equation. So these four equations, and not four. The last two will give you all answer.
Sir,
Yes.
so when we had said that like घूमने का फैलना zero, फैलने का घूमना zero, that was for time invariant.
Yeah. The static.
Okay.
Yeah, those are static fields, not the dynamic fields, right?
Yes.
Correct. So I'll go to the third and fourth question, and I'll show you how to derive it. Derivation of so C is not the speed of light. C is called the Maxwellian constant. And fortunately, because this constant was having the resemblance with the velocity of light, which was already derived by the Foucault and Physio by their simplistic experimental arrangement. So this coincidence was not a mere coincidence, but it was some sort of inherent relation that the electromagnetic property and the speed of light must be having some relation. And because Maxwell proved that relation, so it was the form, now you can say you can say the belief become the very firm that light is also an electromagnetic wave. Okay, so light is also an electromagnetic wave because of this resemblance, the C with the velocity of light. Okay, so we'll see that how to get C. So the third equation is what? Okay, how we derive, I will tell you. Derivation is very simple. If you want to learn, I will show you. I can prove easily using the differential form, but I would like to show you with the JEE level, the integral form. Okay. So the electric field is always. So what I'll do is, we know the electric field we take along the y-axis and magnetic field z-axis. Okay. So the way of solving question is draw a loop. Simply draw a loop like this. And the way of drawing the loop is move x and move. Okay. And then traverse the loop anti-clockwise. So what is the direction of electric field, guys? Tell me. Parallel to the y-axis. So let's say the field here is E, and the field here is, you know how I write, E plus del E by del X into del X. I hope you remember this.
Yes.
So
Yes.
the third, what is the third equation? Third equation was? Okay, you don't remember. Okay, let's say the fourth equation will help you. The fourth is Faraday law, E dot dl, right? And the magnetic field is like this, B. So tell me, guys, what is the flux? So let's say the length of this is L. What is the flux through the loop? Hello, hello. What is the magnetic flux, guys? Because it is from x to x plus dx, the B will be constant over this loop, isn't it?
Yeah.
So the flux converted as B into area. Hello, hello, hello. Can we write B into
Yes.
area? So the d phi B by dt how much? Okay. So d phi by dt becomes BL dx by dt, isn't it?
Sir, sir,
Yeah, tell me.
sir, the change in flux, I don't understand that part, sir.
The
d
flux
phi
through
by-
this area, how much is flux?
So, but isn't the magnetic field varying as
Yeah.
a sinusoidal curve?
So B is varying over x, isn't it?
Yes, sir.
So for a small x, can we assume as constant?
Okay, sir.
Constant,
Yes, sir.
constant in position, but of course it is changing in time. So B for this elementary area can we take as almost constant at one particular instant, yes or no?
Yes, sir.
Why we are doing so? Because it is only between x and x plus dx. Tell me, guys, is this correct? Yes or no?
Yes, sir.
Yes.
So what is the equation? What is the equation of E dot dl? Let's do the E dot dl. You know, the upper and the bottom will have E and dl mutually perpendicular. Correct. So the upper and bottom will give you zero answer.
Yes, sir.
Sorry. E dot dl equals to how much? minus d phi b by dt. Am I right? Tell me, guys.
Yes,
Hello,
sir.
hello. What is E dot dl? Let's do this. E dot dl. So it is, you can name it A, or like this, A, B, C, D. So from A to B, can we say E dot dl is 0? Tell me, guys.
Sir, yes, sir.
Yeah.
So A to B, E dot dl must be 0, no?
Yeah.
Yes, sir.
Then B to C, it will be positive.
Yes.
Yes, sir.
Then C to D, it will be 0 again.
Yeah.
And then D to E, it is negative.
Negative.
Yes, sir.
So let's do this calculation first. So E dot dl, actually you have 4 terms, out of which the 2 terms are 0, right? This is 0 plus B to C is E plus del E by del X dx. And I can clearly see it's into L, right? I hope this is clear to you guys. Tell me.
Yes, sir.
So this turns out to be how much?
Del E by del X into dx into L.
Del E by del X into dx into L, right?
Yes, sir.
So we have this answer E dot dl. And what we have there? The d phi. Yeah, so now I can feel it. This the way of writing will be like this. So d phi v by dt. Yeah, I can see LDX will get cancelled out. So what I can write is, I have to be a bit smart here. Yeah. So what is the flux here? The flux, actually we have to write flux. Magnetic flux I can write as BL correct, guys? Assuming it is the total flux. Then because this is the differential answer is coming in after doing the integration, right? So if I call d phi b this much, so the d phi b by dt, I can write as dv by dt LD. Can we write like this? Tell me, guys, yes or no?
Yes, sir.
I'm taking the LDX as area. Area is constant. Okay. So
Okay,
if I use this the fourth equation of Faraday, using fourth equation of Faraday, can be write and again, okay, this is the partial is better, I think, but anyway, okay, we can do this later on. So can we write, guys, del E by del X L dx equals to minus del B by del T into L dx? Can we write something like this?
yes, sir.
This answer, okay, this answer better you can write as del B by del T. Partial we have to change it because of the multivariable function, but that's okay. So you can also change this equation. Okay, this is if the function is multivariable, make it sure that you write this way. If it is one single variable, you can write exact differential. But these changes you have to be careful. This gets cancelled. So what you get here is del E by del x equals to minus del b by del t. So this is a very, very important relation. If you want, you can even know. So what happens actually, see, this I could have derived easily from the differential from directly. This is the answer, right? Do you remember this part? I, j, k, del by del x, del by del y. And E we can attach Ex, we know Ex is 0, Ey is E, Ez is 0. And it's so one dimension, so I can just start this. And this will give you what? You can get the answer in one day, right? That's why
Yeah.
that del E by del X is. Anyway, so it's up to you. But remember, okay, there's something like this relation. Just look at this. I mean, see, there is no need at all to understand the derivation. I mean, to derive the derivation, do the derivation. You can just be happy with the formula. If you understand, it's yeah. Then
Sir, while finding the determinant, wasn't it an I cap?
no. I cap will give you. This is I j k.
Uh,
Because E is a function of X actually. So if you differentiate with anything else, it will be 0, right?
yes.
That's right. So okay.
Okay. Sir.
Now using third equation, we have to derive the another relation. The third equation was what? B dot dl equals to mu naught epsilon naught, or you can say del phi by dt. I hope this is the answer, if you remember.
Yeah.
So how to draw the diagram to get this answer? Okay. So this time I have to draw a loop separately. I mean, because I want to now calculate the B dot dl. So my loop will be something like this. I hope you can understand this part, right? So here is E. So I can move like this. X. And this is B here. This is. Okay. So if I to call this as L, the B dot dl will give you how much? Can I directly del B by del X L dx? If you remember the last question.
Yes. Sir.
And you can clearly see the flux part. The electric field is like this, normal to the area. So what is the flux part? Come on, what is the flux part? E into L dx.
Yes.
So the
Yeah.
electric flux will be E into
LDX.
L dx. Therefore, the del phi by del t I have to write as del E by del t L dx. I have to be this smart now. So this I can write as again this will get cancelled. So what is the new relation here? Del B by del X is mu naught epsilon naught del E by del. Okay, just a moment. No, just a moment. Just a moment. So do you see some difference here? My answer will be negative here. Because the direction of B we are taking as towards Z axis. So this will give you positive answer, but this will give you negative answer, isn't it?
Yes, sir.
Because our B is this way, na?
Hmm.
And we are moving opposite, so this will be negative. So this is negative. That's why the minus will come into picture. Yes or no?
Yes, sir.
So basically, these are the two differential questions which can derive the answer very easily. So del E by del X. The X differentiation is minus del V by del T. You can see the partial derivative of electric field is the in position is the partial derivative of magnetic field in time, and vice versa. So how to derive the answer, sir? It's very easy. You can differentiate anyone. Once again. So the way of writing is, I mean, of course, you can do this 1 and 2. So what I'll do is I'll just show you one of the way of writing. Del E by del X, you can write as del E by del T into del X by del. Can we write like this something?
So,
Yes.
sir, can we do parametric differentiation? Like just dividing 1 by 2?
This dividing one. No. See, there are two ways of getting the answer. You can differentiate the equation and you will get a what we say a differential equation of second order, which is the wave equation. I hope you remember this fact, what I'm saying.
Yes, sir.
So del E by del X we can write as del E by del T into 1 by del X by del T. What is del X by del T? Any guess?
Sir, the speed of the wave.
Exactly. It is 1 by C. So and now the thing is we have to write del B by del X. So somehow I have to use this second equation also. And from here we can write as del B by del T 1 by C equals to minus is everywhere, no? I have missed something. Yeah. Okay, now we can get the answer. Yeah, we got it.
So,
Yeah, just a minute.
sir, how did the B change to E?
No, just to okay, don't worry. So now we can do this. Del E by del X is how much? Minus del B by del T, correct? And this we can write as del E by del T. I can replace del X by CDT. Isn't it? This is okay.
Yes, sir.
And this is from the first part. And if you use the second one, del B by del X is minus mu naught. And we are done, almost done. So del B by C del T. And can we replace this term? I'm done. You can see here. So look at this, what I'm doing. I'm taking this one and I'm replacing this term from del E by del T from somewhere, from here. Correct? So del E by del T, how much? C times minus del V by del T. Oh, it's hodgepodge now, but anyway. So do you realize this? 1 equals to C square mu naught epsilon naught. Hello, hello, hello.
Yes, sir.
So this is the simple proof. 1 equals to C into. So C square is. So C is. The second thing I have to prove is E equals to CB, right? So for that, I will take the help of the equation of traveling wave. And choose any equation, the del E by del X is minus del V by del T. Using this equation. So differentiate the first equation, what will get? If you differentiate with X, what will get? E naught. And it will give you sin gives cos. And the coefficient is minus Q. And if you differentiate the B, what will get? Minus B naught omega. Sorry. Cos the complete silence is saying that okay, none of you are getting it. Okay. So minus K E naught is minus B naught omega.
Yes.
E naught by B naught is omega by K. Omega is 2 pi f, K is 2 pi by lambda. F lambda by definition is called
C.
so C equals to
E naught by B.
so this chapter is over. So I have proved everything, the Maxwell equation. Okay, now we can do the problem. Just two.
So this just proves it for the amplitude, right? The ratio is valid for any value of C. Any value
Any
of
at at any instant. Yeah, that is valid for at any instant.
So how do you prove that?
Because it is coming here. No? You can see just a moment. Let me go back to the So you can see here what is E naught cos omega t. This is E na with some phase shift, isn't it?
Yeah.
And this is B in general. So minus you can say minus Ke equals to minus B omega, isn't it?
Okay.
So it is always true, isn't it?
Okay. Okay.
Because I'm just shifting the phase, right?
Yes.
It is also sine function.
Yeah.
Okay. So E C equals to E naught by B naught. So we have to take the ratio at the same instant, maximum by maximum, or instantaneous by instantaneous. Anyway. Yeah, I was going through the non-numerical part. Just a moment. New share. So this chapter will come after here, right? Where is the? I think now should come EMU, right? Yeah, I think this is the chapter. So topic is electromagnetic waves, conduction and displacement current. Okay. So you can tell me the answer directly. One more thing is left, but okay, that's okay. We'll just do this. The first question, can you answer this? So in which direction the wave is moving, guys? Tell me. Plus x or minus x?
Plus x, sir.
No.
Oh.
When the sign between the omega, I mean kx and omega t is positive, it is moving in the negative
right.
x direction.
No, minus.
Yes.
So the rule is simple. There are some rules actually. So if we have omega, I mean t minus kx or kx minus omega t, it is positive. And when it is plus, then negative. Understood? So what you need to realize that this wave is moving in the minus x direction. So minus I. So the answer of electric field must be such that the E cross B must be minus I cap, isn't it? Hello, guys, tell me.
Sir,
Yes, sir.
The direction, the sign must be not this value, the sign must be minus I cap.
yes, sir.
Now check which of the following will give you minus I cap if you choose. So K will go with J only, right? But there are two options of J. So C and D is incorrect for sure, isn't it? Hello, guys. So E cross B, which will give you minus I? And look at this. This is minus here already. Be careful. This is plus. So basically, this is the minus J, and this is plus J. And what we want is, and we know B is positive and K. This is K. So we know we have K cap here. So what should be here to get minus I? Come on, guys. Hello.
Sir, minus J cap.
So which option is correct?
Sir, the first one.
No brain. I mean, this is like they write something really big. You may see and get confused, but the answer is very simple.
Sir,
Yeah.
sir, can you just like explain the angle within the sine function?
Okay. Yeah. I think that part you haven't studied. So when we have any transverse wave or any progressive wave, so we write progressive wave as sine or cos, and then we have kx plus minus omega t or omega t plus minus kx. Now you're not supposed to worry much. Just look at x. Whatever you see multiplied with x is k, and look at t, and whatever is multiplied with t is your omega. If the sign between these two terms are positive, the wave will go minus x. And if the sign between them is negative, the wave will go in the positive x direction. Okay. So what is omega here?
Sir, 1.5 into 10 power 11.
And what is k here?
0.5 into 10 power 3. Sir.
So what is the speed of, I mean, the velocity of wave here? V equals to?
Sir, omega by k.
Yeah, it is always omega by k. So the answer is omega by k. Omega we got 1.5 10 per 11, and k we got 0.5, which is 5 into 10 power 2.
Yes, sir.
So this is 3. You can clearly see this is
Speed of light.
3 10 power 8. This is the lightest speed. Yeah. And if it is less than this, it is definitely some medium is there. So they may ask you find the refractive index. So you find the velocity of wave using the formula, and then you divide by the this. I mean, use the relation C by V. So this is your V. Luckily, this V is same as C, which means it's either air or vacuum. Understood?
Yes, sir.
So anyone having any doubt, tell me guys, yes or no? Hello, hello, hello. Okay. Next. Okay, just read the question, tell me the answer.
So 4.8.
You can check the answer. I don't know. See the answer. Is it 4.8? Anybody else getting the answer 4.8? Tell me, please. Receive. Archit, tell me.
So they're not there.
So what is the answer? Answer is not given, you are saying, right?
No, I said Krishu and Archit are not there.
Okay, then. Oh, who all are left me? Okay, only 4. Yeah, you tell me the answer is there. There's a 4.8 is
No.
there.
One second, sir. I'm searching for it.
Go below. No? I have to go below. It's difficult for me.
Sir, I'm also getting 4.8.
So that should be the answer. How many questions are there in this chapter? 26, 27, 29, 35.
Yeah, sir, it's 4.8.
Yeah, very good. And there are some basic information question. Microwave, radio wave, short wave, all this. Okay.
Sir, these theory part,
You don't know?
I guess I have to memorize these.
No, this is known to you. All these are taught in different chapters. What is X-ray? What is radio waves? What is UV rays, right? So in H atom, what we see? Lyman, Balmer, Paschen.
Yes, sir.
So we have the UVN, visible, and IR, right?
Yes, sir.
So you can guess from there, right? So if you know the chapter, then you're not supposed to mug up anything. But anyway, you can read from NCERT, the theory part. I mean, the which wave is bigger, shorter. I have given this already in some chapter. Isn't it, guys? Tell me.
Mm.
The range is given, na? Radio wave is biggest wavelength. Cosmic pillar is smallest, right?
Yes, sir.
Okay.
Yeah.
Read the third question. And it's a trick question. So electric field and magnetic field must be mutually perpendicular,
Yes.
which means the dot must be.
0.
0.
And second thing is the E naught and B naught relation, we know E naught equals to C B naught.
Yes, sir.
So B we can replace by E naught by C, right?
Yes.
So which of the following will give you 0 answer? I think A and B is wrong. So there must be C or D option. Yeah. The dot should be 0. Yeah, A and B. Yeah, that's possible. Yeah, so A option, right? I think 1 plus 1, minus 1 plus 1, right? These are unit vectors. X cap, Y cap are unit vectors. If you take the dot, what will you get?
0, sir.
0. So it means they are mutually
Perpendicular.
perpendicular. Isn't it, guys? Tell me.
Yes, sir.
Okay.
Sir, there was some other option also with dot product 0.
Yeah. Which one? This one, right?
C.
So this
So-
will give you no, this will give you -2, I think.
Sir, x plus y and here x minus y.
No, that is I think minus x plus y.
Sir, in the question it's x
Yeah,
plus
yeah,
y.
yeah. X plus y, yeah, right. So x dot x 1, y dot y 0. Okay.
So the cross should be plus Z because that's the direction.
Yeah, the direction is z.
Yeah.
So
That's
it
what we
must
have.
be plus z. So the answer is must be the cross product must be plus z, and of course, so there are two conditions you have to apply actually. Or just think that z axis, you will get the answer. So now which option is giving the right answer? The z direction. Plus z should be the direction of propagation, right?
Yes.
And D is incorrect because it's a cos. So there is a phase difference. And what I said, the E and B must be in same phase, right?
So,
So D cannot, yeah.
sir, I can understand the statement.
The electric field vector and the magnetic field vector must have the same phase, which means
Yes, sir.
if I express one as a sine of kz minus omega t, the other must be sine only.
Yes, sir.
So in the option D, it is cos, right?
Yes, sir.
So it is phase difference of pi by 2.
Yes, sir.
So that's not the answer. That's why I'm saying this is not the answer.
Okay, sir.
Okay, now solve.
So it should be A.
Yes, sir.
Okay, fine. So, okay, these are same question. I mean, I will not repeat the same. Let's see something new. I mean, there are many questions only based on the direction, like E cross B, E cross B, E cross B. And you have to understand what is the direction of wave and accordingly solve the question. I mean, these all seems to be a similar nature question. And E not equal to C V not formula. I can see the same thing. Okay, solve question number 17. So for maximum force, what we are supposed to do? First of all, the charge is stationary, which means the force must be electrostatic. So you are supposed to find the E value and not E max, which is CB not, right? I mean CB maximum, B max. So what is the B max here? Under root of B naught square plus B naught square. Isn't it?
Yeah.
We got the answer, no? So the answer is
But it's asking for RMS. Now, why are we finding max?
the okay RMS value. Okay, find the RMS. That's it. Q into ERMS. That's it. So I thought
We'll
it's
have to
max.
integrate.
How much?
We'll have to integrate it. E squared dt by.
Why you have to integrate? You know how to find the first. You find the BRMS. That's it. So what is the B square? See, put Z equals to 0. It will be only cos omega t, na?
Sir, we have to first find the electric component, right, sir?
Yeah. First you find the B first. You find the B max. So what is the RMS value here?
Okay, sir.
How to find the RMS? You know this answer, right? So B turns out to be how much? Square cos omega t. So this is the formula. And you know how to find the RMS? It is squaring the function, taking the mean and the root,
Yes, sir.
which means take the mean here and take the root. And we know this is 1 by 2. So answer is B naught square plus B unit square.
Sir, so after, but we can directly apply the functions
Yeah,
on
yeah,
the magnetic.
yeah. So this is the
Oh.
BRMS, right? So what is the ERMS? C times
BRMS.
and the force is Q into E. RMS forces. So I think the answer should be it is 3 into 0.2, right? 3 square and 0.2 square 10 power 5 minus 5 upon 2 minus 5 into 10 power 8 and charge is 10 power minus 4. So 5 for 9 minus 1 0.3 0.3 into 3 square plus okay. 0.9 by 1.4. It's close to 6.6. A option is should be the answer. Can you check? After calculation, the answer is coming close to 0.6. Dash, can you check the answer?
Question number 17.
17. I'm getting.
Yeah, 0.64. Answer is 8.
Now solve the question number 19. That is from the radiation pressure, I think. 19.
Sir, I'm getting B option.
Yeah, you can check now.
Okay, sir.
And what upon meter square is intensity? It is not power, right?
Yes, sir.
Yeah. So I is given. So it's 1 plus alpha, which is 0.25. So 1.25 into IA by C.
Yes, sir.
That's it. So if you have applied that formula, the answer must be right. Is that the answer?
Okay, sir. Sir, I'm checking, sir. Sir, which page number is this?
Let me just a moment. It's 388.
Okay, sir.
388. Yeah. So it is just a formula, no? That's
Yeah, sir, I have to go through radiation pressure once again. I have.
no. This is 1
Right.
plus alpha W by C.
Mhm.
Sir,
And W
yes,
is
sir,
I.
it's B, sir.
Yeah. That's that. So in radiation pressure, just there are 2-3 formulas. You just need to learn how to apply it. The derivation is not required. I mean, if you want to understand, it's really good. So as of now, just spend time in remembering the formula and apply it.
Okay.
Derivation you can do after the JEE-Mains, before advanced, right? Okay.
Yes.
Yeah, for everyone. I mean, as of now, just focus on the formula and how to apply it. After mains, you can go back and see because video is there, notes will be there. You can always go back. Okay, so what I'll do is, I'll end the lecture right now.